Hey, welcome back, Business Analytics. How you guys doing? This is going to be, I think, our third video lecture, back by popular demand. And yeah, this one is going to cover cluster analysis, as you can see by the PowerPoint slide. So, if you haven't already got here, you can go to, it'll be week 13, I believe, cluster analysis inside Brightspace, and you'll be able to download this PowerPoint and then all of the associated files that we're going to have with it. So this is going to be much more like the first video lecture I had, that we're going to have PowerPoint slides, we're going to have a class, an in-class exercise, and we're going to have some data files with it too. So this is going to model that kind of step-by-step sort of recipe first time, okay? Because I got some feedback that is what you guys liked, and I felt like that was probably going to be the case. So that's good. So yeah. So let's get started here. So just as a preface, I am going to try to go as quickly as possible through this, because we have a lot to cover here, and I really don't want this thing to run on for like an hour. I think this is something where you can get the main gist of it in a little bit less time. It's a very complicated topic, in that like we don't even really get into the theory of why this works, and like the technology aspect of it, but like the output reading, that's all very intuitive, or at least the usefulness of it is intuitive. Okay, so I'm going to skip through some things. I'm not going to hit every point on the PowerPoint slide. As always, I know you guys can read faster than I can speak it, so that's good. But yeah, so we're going to cover a little bit on the PowerPoint slides. I'm going to show you some examples on the slides, and we're going to get to a class activity. So you can find all of this stuff on Brightspace. You probably already know that because you found this video in the same spot where you can find all of this other information. So if you want to get the best bang for your buck here, you're going to want to potentially print out the PowerPoint slides, but most certainly print out the class activity, the in-class bank churn exercise. Okay, sounds good. So let's get into it. So cluster analysis. So cluster analysis is what we call an unsupervised learning technique. Okay, so everything that we've done up to this point has been a supervised learning technique. And mainly what that means is that when we used the technique that we were using, we had a goal in mind. It was something where we had a specific dependent variable and specific independent variables, and we had a certain goal in mind. We were looking to predict something specifically. We were looking to find the probability of something. There was a particular goal in mind in order to from a prediction standpoint. Like, so that's the whole idea behind a supervised learning, is there's a prediction aspect. This cluster analysis is an unsupervised learning technique. So it says no predefined outcome groups are necessary, but can include possible dependent variables in the analysis. So what cluster analysis is going to end up doing is we're taking a big thing of data, and it is going to go ahead and partition that data into groups based upon certain qualities of the data. And if that's unclear what I mean, it'll become very clear as we get into an example. So we'll get into certain examples, and it will decide that, oh, maybe these groups should be looked at a little bit differently because they all have a very similar quality in one of their variables, right? So what it's doing is it's grouping different line items. It's grouping different rows of data together because of certain characteristics that they have. Now this is, I don't want to say groundbreaking, I don't want to sound too dramatic, but this is really, really cool because we can take a large data set that has, potentially a large number of variables associated with it. So it's not like just like a small data set where we have like, one or two variables associated with each line item, and it's like, just kind of, easily partitioning it, and doing something that we could be doing with our eyes. This is looking at it and saying, oh, this has this certain quality, and so does this other piece of data, and now we're going to group them together because we think it makes sense. And by we, I mean the computer's technology behind it, okay? So we will get into it. So unsupervised learning, so it does it all on its own. Okay, how does cluster analysis differ from PCA? You guys don't even know PCA. We decided not to cover it this semester. PCA is principal component analysis, and it's similar to cluster analysis in that it is an unsupervised technique, but it is mainly separating on columns and not rows, and clustering is separating on rows. So you don't need to know that, but that's just included in the slides in case I use this again in the future. The main idea provides a way to learn about the structure of complex data. We kind of just talked about that a little bit. So what it's doing is it's dividing the data into smaller digestible chunks based upon certain characteristics that stick out. They don't necessarily have to be outliers. They just have to be characteristics that separate it from the rest of the data. Okay. And then understand data structure with the characteristics of each cluster. Yeah, so ultimately what this is doing is it's just partitioning data. It's just going to be putting data into different groups. And then realistically, once we have clustered that data into groups, we can turn that into a variable in and of itself. And then we can use that in a supervised data technique, like a decision tree. And this can just be really, really useful because it can help us make business decisions at the end of the day. All right. Use of clustering in business. Segmentation for customers. I kind of just started to talk about this. Segmentation for customers, products, stocks, or firms. Patterns of variables form the clusters. I'll let you guys read on about that. I want to get into this example because it is really, really neat. Desirable cluster features. Clusters can be characterized by what members have in common or by what separates them from the customer population as a whole. The distance between two clusters is the distance between the two cluster centroids. That's way more technical than I care to get. So we're not even going to worry about the centroids and any of the math that goes along with that. So don't even worry about it. All right, so we have two clustering methods. I'm going to show you examples of each of them. The bottom-up process, which is the hierarchical clustering, hierarchical. And then the Kmeans clustering. The Kmeans clustering is what we are going to use for our lab, but the hierarchical is useful in and of itself, just for you to learn clustering techniques, and it might be a topic that you might need to know for the test. Okay, but we aren't going to use it on our lab. We're just going to use it for our class, or sorry, for the hierarchical. We might see that on the test. And for the K-means, we're assuredly going to use it in our in-class exercise, and definitely for the lab as well. Okay, so let's get into it. So hierarchical clustering, bottom-up process, joins or links each observation starting with 2 and then adds 1 at a time, and it's visualized by a dendrogram. And then K-means clustering is top-down and starting with K number of clusters and make the observations fit. The K refers to a constant of clusters specified by the user, visualized by points in a scatter plot. So basically, the K-means cluster starts and runs by itself, and the hierarchical starts and runs by itself. The K-means, we have to specify the number of clusters that we want to see there. Okay. All right, method 1, hierarchical clustering. Each observation is considered its own cluster. In theory, the distance between each cluster and all other clusters is computed and the nearest is merged. The process is repeated until there is only one large cluster. The resulting dendrogram gives us the ability to choose the number of clusters and interpret their meaning. All right, so go ahead and get out or download the public utilities data. And we're going to run through this and jump real quick. All right. This is a data file that we may have used before, maybe not, in a way back when. But anyways, you'll find it on our week 13 cluster analysis page. And we're just going to go ahead and briefly state the goal. The business goal: determine types of utilities to study the cost of deregulation. Instead of building detailed cost models for each, we can save time by finding similar groups. The analytics goal: forming groups of similar utilities by clustering using 8 measurements. So the 8 measurements are going to be the 8 variables that we have associated with the utilities. Okay. So go ahead and get that downloaded and use your JUMP software. All right. Now use the graph builder to look at 2 variables, fuel and cost sales. So let's do that real quick. Okay, here we are in the data. We're just going to go ahead and run a quick graph that's going to be kind of what we're looking at in the slides here. So fuel versus sales. And it's just going to plot the names of these companies, fuel versus with fuel versus sales as the labels, if we can get it to work right. Let's see. All right, so we go to Graph Builder and we go to fuel here. We drag it into the Y, and this is just sort of a activity for us. Okay, this isn't something that is necessary like for this clustering. This is just going to show you kind of what's going on with the clustering. All right, so if you get this weird smoother thing, that's not at all necessary. It's not supposed to be there, I don't think. So just go ahead and right click on it and just go to the smoother and just say remove. Okay, and then we don't have to worry about labeling these, I don't think. I'm sure you can go and label these. Yeah, you can go and label these if you would like to see what exact points they are, like which one is, you know, United Illuminating and Kentucky Utilities, like the names of them. And that might be helpful to you, but it's not terribly important. The idea, though, is to get comfortable with the idea of grouping these points together. So what we've seen here, so we've got a graph here. Let's see if I can pull these both in together. I bet you I can. I bet you I can. There we go. That's good enough. All right, so the idea is that we have these points plotted of fuel and sales, okay? And what clustering is going to do is saying, hey, we've got a bunch of these variables. So right now we're just looking at 2 variables. We have fuel and sales, and that's how we're kind of just describing our rows, our companies, okay? And so we have these 2 variables that are currently describing these companies, right? Each one of these points is a company. And clustering is kind of what we see here in the picture, okay? We see that we're just putting a circle around these because they seem similar, just because they seem grouped together. And maybe that's valuable to us. I don't know. Maybe it's not, right? But this is the whole idea of clustering, is that we think if we can group points together or group rows together, because a row is, you know, a unique set of data points, we think we can group these together. Maybe we can have some sort of business value from that. Okay, so basically we see this graphic here. This blue and green and red circles, these are not from JUMP as far as I know. This is just a graphic that the author had put in on the slide. And yeah, this is just, like I said, this is not clustering right here. This is to give you an idea of what clustering is. Okay, so clustering is going to be not us doing a 1-by-1 x by y, but it's actually rolling in all of the variables into the equation, okay, and then clustering based upon that. Okay, so it's much more sophisticated. It's much more strenuous of a calculation, as opposed to, hey, just plot it x by y and kind of visually go ahead and see. All right, so that's the main idea here. So let me get rid of this and get back to the slides here. All right, so hierarchical clustering. I have a tough time with that word, hierarchical. Anyways, so we get back to it. So hierarchical clustering, we're going to go ahead and we're going to run this hierarchical clustering. Okay, so go over to our data, and we are just going to go to Analyze and Clustering, Hierarchical Clustering. See how I'm doing that? All right, and then we're just going to throw all of the variables into our Y. All of our variables except for our labeling variable. Company is going to be our label, just because that's going to label our points. That's just the name of each row, each line item. Go ahead and hit OK. Okay, and then this is going to be our cluster. So it color codes it, which is really, really nice. So it looks like we have cluster 1, cluster 2, cluster 3, cluster 4, and cluster 5. All right. So let's get back over here and get on to the next slide. So we've just performed steps to create a dendrogram. That's what that was called. We decided on the number of clusters. So in here, we can look back and we can actually customize the number of clusters that we have. So you go down to this diamond here and you can tell it how many clusters to recognize. So we stopped here, so we're at 5, and you'll see the number pop up. Save the cluster labels to the table. Now we have a column of data that categorizes each row. So what you're going to do, so this has these clusters shown in our script here, but what we want to do is we actually want to save the numbers next to the row for each line item, so that we actually have that cluster categorizing that specific line item. All right, so we just go to our red triangle here and we go to Save Clusters. Boom. And we see that it populates a column here and it labels cluster 1, cluster 2, cluster 3, you know, that whole thing. All right, moving on. All right, and now we want to interpret the clusters. All right, so we want to know what the meaning of each one is. Like, why did it split it into the specific group that it split it into? So here we go. So we go back here to hierarchical clustering, go to our red flag here, and let's go down to, where did I want to go? Not save clusters, just did that. Oh, cluster summary, duh. Cluster summary. So cluster summary is going to pull up a few things. It's going to show you this kind of crazy graph, and I think that that's just visually a nightmare. So I wouldn't worry about that. But what you really want to concern yourself with is going to be this clustering means summary. Okay, and then what you're going to see, note that like what you see here in our slide, I think is going to be different than what you get in your output here, which is fine. I'm not quite sure why that's the case, but I wouldn't worry about it. I've run this multiple times, and it's come up similarly every single time. So potentially the data just changed from when this slide was made. So. But then what we want to do is we want to look here to figure out, well, what makes a specific cluster special? Okay, like why is it considered a cluster by itself? Like what makes it different than something else? And let's look. What makes it different? All right, so we look at cluster 1. And is there anything that sticks out to you about any of the variables within it? The count is the most of all the clusters. I mean, that's fine. It's only one more than the second cluster, so that's, sorry about that. Goodness. Sorry about that. Let me turn my sound off here. So we're looking at cluster 1, and we want to figure out what differentiates this from the other clusters. All right, so it has a higher count, but the count isn't so substantially higher that like it makes it that much different. The coverage is kind of somewhere in the middle if we're comparing it to everything else. The return is the highest. That's interesting. So it has a high return, and the cost is the lowest. The load is similar to everywhere else. The peak is not the lowest, so it's on the spectrum. Sales is higher end, but not anything crazy. Nuclear is lower end, but not anything crazy. It's not, the bottom or anything like that. And the fuel is kind of in the middle. So cluster 1, and this is very subjective, right? But cluster 1 we could categorize by our low cost, high return cluster. And that is literally how you would categorize this. You would say that this is so you can categorize this by the variables cost and return and say this is our low cost, high return cluster. And that's that. And so this is how you want to think of these clusters. So like you're taking these specific variables and you're turning them into kind of an overarching categorical representation of what the data is. Okay, so cluster 1, which has 7 things included in it, Arizona Public through Florida Power here, these are our low cost, high return power plants, I think is what we're talking about here. Okay, then if we were to look at cluster 2, what differentiates that? This is a higher return as well. Cost is kind of in the middle. Sales is kind of in the middle. And its nuclear number is crazy. So it's the largest. So it has a high nuclear number and a high return. So a high nuclear, high return. That's how we would categorize that cluster. And cluster 3 only has 1, which is interesting. And this would be looks like our low peak, high fuel. Okay, so play around with that. Think about those concepts a little bit. And that's how we're going to handle it. This video is already running long. I want to quickly get through this. I don't want this to be too much. All right, so now we're going to move away from the hierarchical clustering and we're going to get into K-means clustering. All right. K-means clustering. K refers to some constant number. All right. Hierarchical can be cumbersome with large data sets and large numbers of variables. Choose K based on how the results will be used, how many market segments you want to have, and also experiment with slightly different Ks. All right. So K-means clustering, you'll select inputs, select K cluster centers, assign cases to the closest center, update cluster centers, update the means of clusters, reassign cases, repeat steps 4 and 5 until convergence. So this is how this algorithm works. This is not all that important for you to know. It's really not to burst any bubbles, but it is less important for you to know how the algorithm works, and really you want to know how to interpret the output. Okay. All right. So how many clusters? All points are in one cluster, so there's one cluster, and then every point is its own cluster, and so then there's just going to be n clusters or n data points. So this would be one extreme case, and this would be the other extreme case. All right. How to choose K? This is very subjective. Okay, so just be you having subject matter knowledge, convenience, or constraints. So like a business constraint would be you only have a certain number of departments to work on different clusters. So say you have 3 different departments. Well, you might want 3 different clusters if you know that like one cluster is going to, one like cluster of the market segment is going to put one of your departments at capacity, right? So even if there might be four or five different legitimate clusters within the data, you might have to force there to only be 3 clusters that you have carved out, and then just divide those 3 clusters amongst your business constraint, amongst the departments that are willing to use it. Okay, so that would be an example of kind of a business case for a cluster, or for a number of clusters. Constraints of K-means clustering: you need to standardize data to get rid of the differences in scale. Have to select the number of clusters, and all variables are assumed to be equal initially. The more variables, the greater the computational complexity. We're not really going to worry about the computational complexity because we're dealing with a pretty small data set. The data set that we just used is very small. There's 22 pieces. I think the Inclass exercise we used has 10,000 pieces of data, which by like real life standards is not very big. I would call it small to medium in that regard. But okay, so let's get on with it so that we can get on to the example. Jump exercise overview. No, you can read through that. I'm not going to worry about it. Let's do our in-class. Pressing the wrong things here. Let's do our in-class exercise and get rid of this PowerPoint, guys. All right. Okay, so I have this right here. So this is going to be called the in-class exercise bank churn. So you guys go ahead and pull it up. And my Word is wanting to take a long time to load. All right. Sorry for the technical difficulties here, guys. All right. And so I'm just going to go ahead and read through this just in the same way that we would normally do this, or that I've done this in the past. And so hopefully it works out. All right, guys. So this in-class exercise is going to closely model the way that the lab is going to go. All right. So I'm just going to go ahead and read through it, and we will talk about everything just in the same way a lab would go. All right. So, in-class exercise, cluster analysis, data mining step 1, develop a business research question or goal. The churn rate, also known as the rate of attrition, is the percentage of subscribers to a service who discontinue their subscriptions to that service within a given time. For a company to expand its clientele, its growth rate, as measured by the number of new customers, its growth rate as measured by the number of new customers must exceed its churn rate. The rate is generally expressed as a percentage. Business goal. Churn rate is an important consideration in the banking industry for both retaining bank customers as well as retaining customers to their services, such as credit cards. In many geographic areas, several companies are competing for customers, making it easy for people to transfer from one bank to another. If 1 out of every 20 customers discontinued their credit card service within a year, the annual churn rate for that bank would be 5%. So that's just an example. To be counted as part of the churn rate, the customer does not necessarily have to move his service to a different bank. They just need to terminate their relationship with the current bank, meaning we don't need any outside information. We just need to know information about our data set. Okay. Analytics goal. Who is likely to cancel their credit card at the bank? All right, to accomplish this, you will create market segments of customers. What just happened to my data set? I hope nothing bad. Okay, we're good. Create market segments of customers. Build a decision tree model to predict the likelihood of a customer churning, that is, canceling their credit card. All right, so data mining step number 2, obtain the data. The data bank churn XLS came from the residents of a small community for 1 year's worth of spending habits. Each row or case in the spreadsheet corresponds to one market test customer. There are 10,000 total. The variables in the data set are listed in the table below. Okay, so I give you, in this example, I forget what I do in the lab. Let me see here. Yeah, it looks like I give it to you in the lab as well. So we give you the data types in here, and then you're going to have to go into your file and switch these data types to make sure that the file is in agreement with what we have here. Okay, so we have all these data types here. And again, you should have this printed out so that when I go and work in Jump, I don't have to kind of keep going back and forth page to page. All right, so we have all of these variables. We have the data types. We have our data dictionary here to understand what each variable means. All right, and then it says instructions: download the data to your computer via Brightspace, launch Jump, open the data file, make necessary changes in the data type on Jump as per table 1. That's what I just talked about. So let's go ahead and do that together real quick. So we get over to Jump. Cool. All right, and so for age, that's going to be continuous. For gender, that's going to be nominal numeric. So column info, nominal numeric. Marital status, nominal numeric. Dependents, nominal numeric. And income is continuous. Years of the job, continuous. Years in town, continuous. Years of education, continuous. Driver's license, I'm not going to scroll over in the data. I'll just do it over here. Driver's license is going to be nominal numeric. Do they own a home or not? Also going to be nominal numeric. And the churn rate, yes or no, is going to be a nominal numeric. Nominal numeric, I mean, we've done this a ton before. I mean, you guys obviously know what this is, but this just means that it's a nominal variable expressed in a numeric form, expressed as a 0 or 1. Okay. All right. So we've done that now. So I'm going to move on to, and I really don't want to like switch back and forth. I'd rather just look at Jump here. So I'm going to trust that you guys can follow along with what I'm talking about, and I'll try to reiterate as much as possible. So I'm moving on to the portion of the in-class exercise that is labeled Data Mining Step 3, Pre-Processing the Data. And I'll read number 1, and it says, analyze the distributions of variables and answer the following questions. What is the average age of the bank customer? Of the bank customer. Okay, so, and it gives us 4 questions here. So this is the same thing that we do in every single lab, where we have a data set, and what we want to do is we want to analyze the distributions of all the variables. Okay, so we just go ahead and we run through this. Okay, and me highlighting the whole thing is me just holding down, is it Shift? It's Shift and then the arrow key. And then I just bring all that into Y and hit OK, and it runs a big old script. All right, and I just say stack, and then we can look here and find the answers to the questions that we need. So we have our distributions here. So the difference in this lab is we're just going to ask you some questions on the distributions, as opposed to what we normally do, and we say, hey, take a look at these distributions and tell me if there's anything that's out of ordinary. Okay, this time we're actually just saying, hey, look at these distributions and give me some of the descriptive or summary statistics based on these distributions. Okay, so number 1, analyze the distributions of the variables and answer the following questions. So we have these here on our screen now via our analyze and distributions and pulling all the variables in. What is the average age of the bank customer? So we go to the age variable, and we just want to know the average, so that's mean. So it's going to be 42.1055. So that's our average age. What percentage of customers are men? Okay, so we go to gender, and then we want to know probability. So, one thing we need to remember is, okay, well, what categorizes a male versus a female? We look in our data dictionary, we see that gender, 1 is considered male, 0 is considered female. Okay, so we go back here. So 1 is to signify male, so the percentage of customers that are men is going to just be that probability, or the number over the total. So it's going to be 59.52%. Okay, how many customers are divorced? So we go to marital status. And if we go back to our data dictionary, right, we see that marital status 0 single, 0.5 is divorced, and 1 is married. And so we're just looking for the 0.5s, how many customers are divorced. 1,799. Okay, we're not looking for the probability, we're just looking for the count. And then what percentage of customers churned last year, meaning they left, or they left whatever product we wanted them to be on. So we just go down here and look at churn, and without me going over to the data dictionary, you can look at that on your own. Churn, 1 is yes, 0 is no. That's usually how things happen. Usually 1 is the affirmative and 0 is going to be the negative, okay? So we look down here at churn, what percentage of customers churned last year, and that's just going to be 31.65%. Cool, cool. All right. All right, so the next thing here, well, I'm going to go ahead and save that, as we generally do when we run a distribution. Go ahead and save script to the data table. We can call it distribution. Sometimes it's conventional to call it, whatever number it is that you're working on in the lab. That's fine as well. Or to give it a different name. Okay, so I'm going to go ahead and X out of that. And I'm going to get on to data mining step 3, preprocessing data. Number 2. So it says run the cluster analysis in JUMP. Run the cluster analysis in JUMP using the Kmeans method. Include all variables, analyze, clustering, and Kmeans is where we're supposed to go. So we go analyze, clustering, Kmeans clustering. Okay. And it wants us to run everything. So let's run everything. So we just throw everything into the Y. We hit OK. And then it's going to ask us, how many clusters do you want to do? So choose 5 clusters and then save them to the table. All right. So we hit 5, then we hit go, and then it runs it. It runs all these clusters. And then what I'm going to do is save them to the data table like it has asked us to do. So we go here. That is if we want to save the script, which I'll go ahead and save the script as well. So I'll save the script, but saving the clusters to the data table, we go to Kmeans cluster and cluster equals 5, and we hit save clusters. Okay, and if we X out of here, what it's doing, like I kind of showed you during the PowerPoint slides, is it's putting a column and it's labeling each row by the name of its cluster, and then a statistic, or like a mathematical statistic, that is used to determine what the cluster is. That you don't need to know anything about. Okay, this has something to do with principal components, or a concept of principal components. That's basically, I shouldn't say basically, that makes it sound like it's easy. It's not easy. That is kind of a confluence of all the variables put together, and then they turn that into one number, and then that's going to like help to partition these clusters. Don't worry about that though. Okay, so cluster. All right. So then what else? Okay, list distinct. So you should get, if we look at our Kmeans cluster, okay, this cluster here, this should be something very, very similar to what you are seeing in the in-class exercise. Okay, so the thing that you generate should be very, very similar, if not the exact same, to what we got. Excuse me, it's getting late. To what we have in the in-class exercise. So if you got the exact same numbers, you know you are on the right track. All right. So now I'm looking at data mining step 3, number 2, part B, where it says list distinctive qualities of each cluster based on the means from the table. And so this is kind of what we were doing in the PowerPoint slides, where we look at the specific clusters and we try to pull out things that make them different than the other clusters. Okay, things that are based upon a specific variable that kind of makes it stick out. Okay, All right, so looking at B, let's see here. I just want to make sure you guys know where I'm at. So I'm looking right here. B, list distinctive qualities here. So I'm looking at this cluster, and what is something that makes cluster 1 stand out? So as we kind of walk across here, let's see. Age is similar to everybody else. Gender, similar to everybody else. Marital status, similar. Dependence on the lower end, but very similar. Income, 67, is on the higher end. That is the highest, so that's notable. Years on the job is similar to everywhere else. Years in town, similar to everybody else. Years in education, significantly higher than the other clusters. Driver's license, meaning do they have a driver's license, similar to everywhere else. Home ownership, kind of in the middle of the pack. Credit cards, kind of right in the middle of the pack, not that dissimilar than anybody else. And churn, kind of in the middle of the pack. So it seems like the two qualities that stick out are that these they have the highest income. Cluster 1 has the highest income and the highest number of years of education. So those would be two distinct qualities for cluster 1. Okay? Then, if you want to get a little bit further into the packet, which we will, I guess we can kind of do these together. So B and C sort of go together. So B is like, let's look at our specific distinctive qualities in the data. Like, what are variables? What are aspects of the variables that we think set them apart from the others? And then in C is just give that a creative name. Okay, and yeah, it can be a cutesy creative name. All right, so for cluster 1, we saw that they had a high income and they had many years of education. These would be our highly educated high earners. Okay, that's not cutesy, that's just accurate, right? But it is what it is. And then what do we got here? So cluster 2, age-wise, they're the youngest, right? They're the youngest here. Income, they earn the lowest. And it doesn't matter like if we would expect that. These are just things that are notable, right? I mean, like, yeah, you would expect the youngest to earn the least amount of money just because they have the least experience, have assumingly been on the job the least amount of time. So years at the job, they also, right there, that's what I was talking about. Years of education, about normal. Driver's license, almost all of them drive, but that's similar to everywhere else. Own a home, none of them own the home. Or 2% own a home, whereas everybody else seems to own homes at a much higher rate. So the three qualities that we saw were they're young, so they're the youngest. They are the lowest earners, and they don't own a home. So the young, poor, and homeless, that's what we can call them, right? So that'll work. All right, cluster 3. What do we got? They're kind of an average age, gender similar to everywhere else, marital status. They're married at a higher rate, so that's notable. Dependents, they have the most dependents as well, but it's not like crazy out of the ordinary. Their income is right in the middle of the pack. Years on the job, kind of in the middle of the pack. Years in town, similarly. Years of education, similarly. Driver's license, who cares? Own a home. They almost all own a home. That's notable. So, what can we call them? So, owning a home, they're like almost for sure own a home. And many of them are married. So, these would be like your average Joe couples that own a home. Your average Joe married couples that own a home. Okay, that would be a name that you could call that group. I don't know. You come up with a better name for the group. Okay. Yeah, this is the thing that we actually do. Yes, believe it or not. I think this makes it a lot easier to identify the data as well when you give it kind of a silly name, just because you can sort of caricature and characterize, the groups as opposed to just viewing them as numbers on the screen. Okay. All right. Let's do cluster 4. We'll just go through all these clusters. All right, we got age, it's about average, gender, whatever. Marital status is whatever. Dependence is whatever. Income is kind of middle of the pack too. Years on the job, it's fine. Years in town, they're a little bit newer to town, but it's not anything unreasonable. Years of education is similar. Driver's license is similar. Own a home is lower. And whoa, credit cards, wow. So they have almost 10 credit cards, this group. All right, and their churn rate is 1, which means they're 100%. So they have a 100% churn rate. So the two variables or the two distinct qualities that we would go with is they have a ton of credit cards and their churn rate is unbelievably high. So let's call this group our Mall Madness, right? Anybody remember that game? I will not admit to playing that game when I was younger. So Mall Madness, right? All right, cluster 5, 56. So they have the highest age, so that's interesting. What else? Income is normal. Years on the job, normal. Whoa, driver's license is like super low. All right, and looks like so these are going to be our old folks that don't drive. Right, so they're the oldest and they don't drive. So our old folks that don't drive. Okay, so you come up with whatever names you want to come up with, that's fine. But this is an activity that we're going to go through, and this helps us to divide these kind of groups, name these groups. All right, and then on step D in the same section, it says change the name of the column that you created in the data sheet to customer segmentation. Okay, so the cluster column, we're just going to change that to customer segmentation. All right, so now we have segmented these. So now it's no longer just called a cluster. We've said, oh, we have customer segment 1, customer segment 2, customer segment 3. Okay. And you can always, change those to whatever silly name you want to do as well. Okay. So now let's get on to data mining step 4, choose and build a model. All right, so to be able to see if these newly created marketing segments are important in predicting the likelihood of churning, we will include the clusters as a variable in our model. Number 3, use JUMP to run a classification tree or a decision tree to classify churn as yes or no, and use all the original variables plus the new customer segmentation variable. Be sure not to include any extraneous columns that were saved from the analysis, and do not create any validation column. So basically what this is saying is, so we're going to run this as a decision tree, and the only thing that we don't want to use really is this distance column, because we don't really know what it means, and it's probably going to highly correlate to our clustering column or our customer segmentation column. All right. The only thing that's special about this is it's telling us not to use a validation column, which we would normally create a validation column, but we're instead just going to use the validation capabilities within the decision tree itself. Okay. And I'll show you how to do that. So luckily you can always rewind it and do that. But so let's go ahead and do that. All right, so we're going to do our decision tree thing. So let's go to Analyze, Predictive Modeling, Partition. Is that right? I believe that's right. All right, and we are going to put everything into our X, except for churn. And churn is going to be our response variable. So we're going to hit OK. and we're going to get something that looks like this. And if you get something that looks like that, you're good. You're golden. Oh, no, you're not. Or am I? I'm going to X out of it real quick. We'll go ahead and do that again. So I just want to make sure I don't remember if I put in the 60% that we're supposed to be putting in for the validation portion. So we go to partition again. Ah, it is in there. Perfect. All right, so we're going to say churn in the Y, everything else except for that distance in the X. We hit OK. We get this. We say color the points. We also say we just want to see our probabilities, not the weird g-squared statistics. Okay, so we have this, and we just tell it to go. And then it runs this crazy big decision tree table like we are used to from decision trees. Okay, and so then in step 5, it is asking us to give the top 3 variables that split this thing. So what we want to do is we want to prune our decision tree as much as possible all the way down to the initial node. So we just keep clicking prune until we get down to 0 splits. And then we want to see what does this thing split on. What are the first 3 variables that it splits on, and then those are going to be the variable 1, variable 2, variable 2 again. So it should be variable 1, variable 2, variable 3. All right. So we hit split. So it splits on the number of credit cards. So that would be what we would put in to our variable 1. Split again, and then it splits on customer segmentation. So this is this clustering that we did. So we can already see that this is an important split. It's the second most important split right off the bat. We split again. It's another customer segmentation. So that doesn't go as our third variable. It's just we get a credit card next, customer segmentation after that, and then finally years of education. So listing the 3, it would be credit card, customer segmentation, and then years of education would be our top 3. All right, and so that's that. So I'm going to just hit go, and so that's just running the whole tree. And remember, when we run that whole tree, it's gonna optimize the number of splits that it wants to do based upon when R square peaks. So whenever R square gets to the top of whatever R square should be, it's going to then decide, okay, we have explained enough variation in the model that we no longer need to split the tree. All right, so it decides your split might be different. You might not have 18 on the screen, and that's okay. You might have gotten different variables than me. That's okay. That's just going to all be based on the validation. So you probably remember that from the lab. Like, you should have different numbers of splits than other group members and whatnot. Step 6 just says, hey, paste the leaf report here. So we need to first call up that leaf report, and that's just by going to our red flag and leaf report. Okay, so we go ahead and paste that. All right, so now I'm looking at number 7. Write the top rule with high probability for churning and the top rule with high probability for a not churning below. All right, so churning would be a 1. So if I wanted to write the top rule, I could kind of visually look here and try to see. What I could also do is just I could click on here and then say sort by column and then sort ascending. Let's just do that. Sort ascending. And then I get the top probability here. And then I also get the bottom probability here. So for the if-then statement, my if-then statement would just be, so for a high probability of churn would be if the credit card number is greater than or equal to 5 and the customer segment is 4, meaning it's cluster number 4, which cluster number 4, if you recall, was our Mall Madness cluster, right? This is the people who owned a ton of credit cards and had high churn, oh, well, obviously then they would be people who have high churn, right? So cluster 4, own a ton of credit cards, then have high churn. Cool? Cool. So that's cool. And then for the second portion, which is did not churn, we want to look down here at the bottom of this report. And then we would say if it is a customer who owns less than 5 credit cards and is in customer segment 1, 5, 2, or 3, and has credit cards less than 4, okay, and has education less than 20, they are 99.99% likely to not churn. So really you can then simplify that and say number of credit cards less than 5 and the number of credit cards less than 4. That's just really just the number of credit cards less than 4, right? So you can say this is going to be somebody in customer segment 1, 2, 3, or 5, and they have less than 4 credit cards, and they have years of education less than 20. They are 99.99% likely to not churn. Okay? Cool, cool. I was trying to keep this under an hour. I'm almost succeeding. We're getting close here. And let's look. And now I'm looking at number 8, the data mining step 6, deploy the model. Think about what a promotion plan might look like based on the insights from this cluster analysis and decision tree. How can these clusters help the bank? Okay, so that is, I guess that's something I want you to think about. All right, so we have decided, we've talked about kind of a little bit of the business case in that churn is bad for the bank, right? Without getting into like any, I mean, we didn't really have any high-level analysis on this. We just said that it is important that we keep customers and that churn is expensive for the bank. Okay, so what could we do with this information? We could, because we can segment these customers into customers that have higher than average churn or ridiculously higher than average churn, maybe these are customers that we just wouldn't offer loans to, or we wouldn't want to sign up for credit cards, right? So if this is the case, and we view churn as a bad thing, looking at our Leaf report, well, heck, the thing that we just wrote down, okay, the thing that we just looked at, to almost guarantee somebody having high churn is they're going to be somebody who has more than 5 credit cards and is in customer segment 4. Okay, so if they're in customer segment 4, if they're somebody that is located in that customer segment, that's a customer that we don't want to market to because they're going to have higher churn rate. So then it would become important to be able to identify the customers that would be in that cluster. Okay, I want you to think about that. There's probably some more business insights that you can take. I'm trying to end this video before it gets to an hour. We're at 58.5 minutes. I hope you guys enjoyed this video. I hope you guys get something out of it. I guess come with questions if you have them. But hopefully this models the way that we're going to do the lab on Wednesday a bunch. Please email me if you have questions or if something was unclear on here. But yeah, I will see you guys in lab on Wednesday. Take care. Bye.